Radical Dude here, and today what we're going to talk about is all the possible outcomes for March Madness bracket. And I'm going to just make it really start off really simple, and we're just going to look at taking a shot. So if I take a shot here in the lovely Tompkins Square Park, as you can see, I'm surrounded by all my fans. I have to tell them to back away a little bit because they're hounding me for autographs. So when I take a shot, there's only two outcomes. I can either make it or miss it. So since those both start with M, I'll call it a hit or a miss, H or M. So there's only two outcomes. Now we all know I'm gonna make this shot. So just say, let's keep it going. So you have two outcomes, hit or miss. Now, if I do it again and I put them together, what are the possible outcomes that I have on two shots? So I can either hit and hit, or hit then miss, or I could miss the first one, hit the second one, or I could miss them both, which I don't think will happen, as you'll see right now. I am not missing them both. Hello, I'm over here. I am not missing them both. Huh. It went in, right? All right. I cut. Now, here's the thing. When I did two shots, there were four outcomes. So do we go 2 plus 2 or 2 times 2? What's the pattern? So we could try it with 3 shots. Let's think about what the outcomes would be with 3 shots. So you can have a hit, and a hit, or a hit, a miss, and a hit. So write out all the outcomes, and then what we're gonna do is we're gonna go to the chalkboard. I'm gonna show you the math behind the outcomes. So then you will be able to decide, am I adding the numbers or am I multiplying the numbers? So when I do 3 games, is it a 3 shooting outcomes? Is it 2, 2, and 2, which is 6, or is it 2 times 2 times 2, which is 8? How many different choices do you have? And just start listing them. Miss, 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 hit, miss, 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 hit, hit, miss, miss. List them all. See how many you get. And then we're going to find out if we multiply or add. And that will help us find out how many outcomes there are to March Madness. Okay, let's take a look at that basketball problem. So if I do one attempt, what are my choices for that? I can either score or miss. So one attempt is 2 outcomes. Now, let's try 2 attempts. What are my possibilities? Well, I can either score, then score. I could miss, then miss. I could score first, then miss the second shot, or I could miss the first shot and score on the second shot. So what is that? That's a total of 4 outcomes. I don't know why my tablet's not working very well. 4 outcomes. So I have 1 attempt, 2 outcomes, 2 attempts, 4 outcomes. So you could say we either are multiplying by 2. Let's see if that works for 3 attempts. Those 3 attempts, what are all my outcomes? Well, let's take a look. I can either score on the first shot, score on the second shot, and score on the third shot. I could score, miss. I could score, miss, score. I could miss, score. What other things I could do? I could score, miss. I could miss, score, miss. I could miss, score. Or I could, which won't happen, I could miss. So there's 8. 8 outcomes. So how do we get these numbers is this is 2 to the first power. This is 2 to the second power, and this is 2 to the third power. So to get your outcomes, it's what are your choices to the amount of attempts. So we're not adding, we are multiplying. So if I have 4 attempts, for 4 attempts, it would be 2 to the fourth power. My tablet's not working well, which is 16. 16 outcomes if I took 4 shots. And that's the exact same way it's going to work for March Madness when you're picking teams. Okay, so let's look at what happens when we have 2 teams. So we're going to have A versus B. There are only 2 outcomes. Either A can win or B can win. So there's only 2 outcomes. Let's go back to the final 4 and let's make it A and then B over here, C, and then D. So now you have 4 teams. Well, what I'm saying is that the choice of B and D winning, you have 2 possible outcomes. And the choice of A and C winning, you have 2 possible outcomes. So there are 4 teams. Now, what do I do with those 2s? Am I going to add those 2s for all the outcomes? Or am I going to multiply those 2s? And I'm going to list it. You're going to multiply those 2s, which is 8 outcomes. Or you could just count up the games. A playing C is 1 game, and then that winner plays. B playing D is 1 game, and then that winner will play. So there's a total of 3 games. So what I do is I take the 2 outcomes and to the third power, and that works because 2 times 2 times 2 is 2 to the third. And there are 3 games here. So the number of games you want is in the power. Will tell you the number of different outcomes. And I'll show you I'll list you all the outcomes for these 4 teams. And as you can see, here are all the March Madness outcomes with just 4 teams. So you can see that in red I circled who the champion would be, but these would be the outcomes. So you could see from the top left, you have A, C, and then A wins. On the other side, you have B, D, then B wins, and then A is the champion. That's how you read those. So there's 8 just from these 4 teams. So you can see how it expands and the possibilities are really big, and it will grow exponentially. Now imagine even going further back. So if we can go further back, now you're going to have 2 here, 2 here. So we would do A, B, C, D, E, F, G, H. Now we have the Elite 8, and then there's 2 choices here, 2 choices here, 2 choices here, 2 choices here. So now you would have 2 times 2 times 2 times 2 is 2 to the 4th times all this that we already had. So you're going to have 2 to the 4th times 2 to the 3rd, which is 2 to the 7th, which is 128. So you would have 128 possibilities just from the Elite 8. Okay, first we're going to try to find the total number of games in the tournament. Well, we're going to do the ones in the bracket. So to find out the total number of games, we start with the number of teams. The number of teams in the bracket is 64. So we're going to start there. We have 64 teams. And from these 64 teams, how many games can you have? Well, there are 32 group pairings, so you have 32 games. And there are no ties. So after those 32 games are done, how many teams are left? Well, half the teams go, and now you're left with 32 teams. Now, with these 32 teams, how many games can you play? You can play 16 games. So, from those 16 games, when they're done, how many teams are left? There are 16 teams left, which they call the Sweet 16. 16 teams left. How many games can be played on those pairings is 8. There are 8 games remaining. And out of those 8 games, when they're finished playing, half those teams go home, and now you're left with 8 teams, which they call the Elite 8. Now, from there, you have 8 teams. How many games can you do? That is 4 games. So you play 4 games, half those teams go home, and you're left with 4 teams, which is called the Final Four. Now, from those 4 teams, how many games can you play? You can only play 2 games. And now you're left with 2 teams. From those 2 teams, how many games can you play? From those 2 teams, you can only play 1 game. And then you're crowned a champion, right? Now, we want to find out how many games there are in total. So we just count up the number of games. So we have 32 games here, plus 16 games there. That's 48, plus 8 games here. That's 56, plus 4 games here. That's 60, plus 2 games here. That's 62. Plus 1 game here, that's 63. So there's a total of 63 games. So we start with that. Okay, let's use the geometric series formula, which is s to the n, the summation. This is more for advanced students, times a, the amount you're starting with as you decrease. Then the formula goes r to the n minus 1 divided by r minus 1. I might prove this in another video. So what it means is this. We're summing all the games, and we're starting in that bracket only. So there are 6 rounds, so the n is 6. So that's how that goes. The number of games it will start with is 32. That's where the a becomes. Now the geometric ratio is each time they cut down by half. So you have 32 games in the next round, 16 games, 8 games, 4 games, 2 games, 1 game. So your r is a half. So the r is a half. I'll put that in parentheses. The n we said was 6 minus 1 divided by a half minus 1. Once you plug all this in, then the rest of it is just standard arithmetic. This is 32. This is 1/2 times 1/2 6 times. It's 1 over 64 minus 1 divided by half minus 1 is negative a half. And then we have, where's my marker here? We have 32 times, well, this is 1 over 64 minus 64 over 64 divided by negative a half. So then we're going to have what? We're going to have 63, negative 63 over 64. This is just a boring arithmetic, but it could be fun if you like. And then what do we have here? Well, this goes into this. 32. Oh, no. What happened here? This goes into this. So we have negative 63 over 2 divided by negative a half. The 2's cancel. The negatives cancel. And now we're just left with 63. That's the easiest way to do that. You would use this formula if there were an immense amount of rounds, right? There's 15, 20, 30 rounds. You don't want to just keep counting them and adding half, half, half. So you'd use that geometric series formula. So now let's look at the total number of outcomes. First of all, we know that there are 63 games total, and there's 2 choices per each game. There's a total of 2 outcomes. And as I said before, we multiply these outcomes. So you're going to do 2 times 2 times 2 times 2, and you're going to do it 63 times, which is the same thing as 2 to the 63rd power. And what is 2 to the 63rd power? It's a very large number. Let's write it down. It's 9, 2, 2, 3, 3, 7, 2, 0. Whoops, that 0 went a little high. 3, 6, 8, 5, 4, 7, 7, 5, 8, 0, 8. So let's see what that is. So here we get the millions. This is the thousands, the millions. Uh-oh. Oh, no. Here we get the billions, the 1,000 billions, the million billions, and the billion billions. So there's 9.2 billion outcomes, which is 9.2 quintillion. A billion they call a quintillion. So, what does that mean? Well, there's roughly 8 billion people on the planet. Let's see. There's roughly 8 billion people on the planet. So let's make it 9 billion because we're heading to 9 billion people. That will make it easier. We're heading that way anyway. So if there's 9 billion people on the planet, then if all 9 billion people filled out that March Madness bracket and all different, just say they did it all differently, it would take 1 billion years to make sure that all the different outcomes were covered. 1 billion years. So when your bracket is broken, don't get upset. It's what's expected. Action. This has been Radical Dude, and I hope I was able to teach you something.